Hello students, welcome back to CLARI Concepts, Unleashing Conceptual Learning. For more videos on engineering concepts, you can log in to our website www.clariconcepts.com. Today in this lecture, we are going to talk about pressure variation in a static fluid, and this will be really interesting video for all of you. And once you go through this video, you will get exact clarity on what happens to the pressure when you go horizontal direction or when you go in downward direction or vertical direction, right? So when you have a fluid at rest, and what is the behavior of pressure along horizontal and vertical direction. So in this lecture, you are really going to enjoy a lot. So stay with us. So let us take one funny example that you went to a swimming pool with a pressure gauge in your hand, okay? And you jumped from the top of the swimming pool and your task is to go to the bottom wall and walk a bit. And I would request you to keep an eye on this pressure gauge. What happens to the pressure gauge at different position of yours, right? So let us look at that. So what did you observe? Look at it one more time very closely and then I'll ask you. See, what did you observe? That when you were moving from top to bottom, the pressure was increasing. The pressure gauge was showing you the deflection in the needle. And when you started moving horizontal direction, the pressure gauge needle was not changing. That means it has showed you the same pressure. Why is it so? So let us now understand this why and answer this why. Okay. So let me first take 3 points in the corner. One is point A, one is point B, and one is point C. Alright. Now, point A is open to atmosphere and therefore the pressure at that particular point will be atmospheric pressure and which is 0 Pascal gauge. So, all the points on surface of water will be at atmospheric pressure. Clear? Now, my concern is what is pressure at point B? What is pressure at point B? That is the question. So, let us find out this pressure using the hydrostatic law. Can we do that? Obviously, yes. Why? Because I have a pressure at a point which is above B, which is point A. And if I know the distance between point A and B, which is 3 meters, I can easily use the hydrostatic law and figure out the pressure. Okay, let us go ahead. So, let us apply hydrostatic law between point A and B. I will say that pressure at lower altitude point equals to pressure at higher altitude point plus rho g h. Now, what is pressure at lower altitude point? That is pressure at B mainly. Then A is at higher altitude point PA and rho GH. Now let us put the values. What is pressure at PA? 0 Pascal. What is rho? Rho basically is density of the fluid. So it is 1000 kg per meter cube. Basically it is water. Right. What is G? Value of G is 9.81 meter per second square. H is the distance between A and B, which is 3 meters. Now substitute all these values in the equation. You will get pressure at point B, which is 29430 Pascal gauge pressure. So you put the value 29430. Okay. So now if you look at the variation of needle, pressure at point A was 0 Pascal, pressure at B is 29430. That means pressure is continuously increasing from 0 to 29,430 Pascal. And therefore needle was constantly showing you deflection. You can again see. Therefore it is showing you the constant deflection. Yes, increasing deflection. Alright. Now let us look at pressure at point C. Can you find it? How? Do you know pressure at any point above C? Yes, I do know. I can project a line on the surface of the water and I can say that the point is D. And since D is again exposed to atmosphere, pressure at D will also be atmospheric pressure, which is 0 Pascal gauge. And now you know that if B and C are located on the same horizontal line, that means this distance will also be 3 meters as the distance between A and B. Now we can use the hydrostatic law between C and D. You will put PC, which is the lower altitude point, equals to PD plus rho GH, where PD is 0 Pascal, rho is 1000, G is 9.81 and H is 3 meters. You put all the value in this equation, you will get the pressure at point C. And you will find pressure at point C is 29430 Pascal again. So if you see PC is also 29430. So now you compare B and C, they are both same pressure, which means pressure at all the intermediate points between B and C will also be equal. And therefore, the needle was not showing you any deflection when you moved from B to C. It was showing you the constant value. Yes or no? So what does it mean? It means that when you move in a horizontal direction, the pressure is not changing. When you move in a vertical direction, downward pressure is increasing. So what you can say? In a fluid at rest, the pressure at all the points lying on the common horizontal plane is same. You see, pressure at all the points between B and C which lies on the common horizontal plane is same. I can also say pressure at all the points on this horizontal plane is also same. But it does not mean that pressure at this plane and pressure at this plane will be same. They are both at a different height. But yes, you can say that pressure at all the points lying on a common horizontal, see it is written common horizontal plane will be same. Yes? Okay. Now let me ask you several questions. I have few points A, B, C, D, E at different heights and it is already mentioned. Now let me ask you, what is the pressure between C and D, or what is the relation between pressure between C and D? Both of them are at 3 meters of depth. What can you say? Whether the pressure are equal, whether pressure at C is less than pressure at D, or whether pressure at C is greater than pressure at D. Which one of these three you think is correct? Obviously pressure at C and D are equal. Why? Using this principle. You see, both of them are lying on a common horizontal plane, and therefore pressure not only at C and D, at all the points on this line will be equal. Yes? Okay, let me ask you about pressure at C and E. You have three options. Whether pressure at E is greater than pressure at point C, number one. Then number two, whether pressure at point E is less than pressure at point C. And number three, whether they are equal. What is your answer? Now I think you must know the answer, right? Since E is at lower depth, pressure will be smaller than comparison to pressure at C. So pressure at E will be less than pressure at C, which is option number 2. And remaining 2 are incorrect. Yes? Now tell me the answer of this question. At which point the pressure is highest? A, B, C, D or E? Where do you think? You look for the point at the maximum depth, point B. Therefore pressure at B will be highest in comparison to all the others. Right? Okay. Now I would say, after learning this much, I would say this statement is incomplete. You will be amazed. Yes, this statement is only true this is only true when the entire tank is filled with one single fluid having a common density. So here the entire tank is filled with water, say for example, then you can deploy this statement at different points in the water. But what if you have a tank and you have different fluids? This statement will not hold true always. So let us see which is more convenient and generalized options. So let us say I have this weird looking tank with me, and I have mercury filled in one of the pocket, and density of mercury is 13,600 kg per meter cube, and in remaining portion I have water filled, okay, and density of water is 1000 kg per meter cube. Now I will mark several points in the tank, point A, point B, then point C, point D and point F, okay, and I will try to explain you the concept. So let us say point A and B are on a same horizontal plane, and the depth of both of these points from a free surface of water is 10 meters, okay, and now point F is located at a depth of 8 meters, and then the depth between F and D is 3 meters, and D and C are also located on a same horizontal plane. Now if I ask you that between point A and B, which one of these is correct answer? Whether pressure at point A is greater than B, whether pressure at point A is less than B, or whether pressure at point A and B are equal. So let us first find out what is the exact answer. So how will we do that? Firstly, I will calculate pressure at point A, then I will calculate pressure at point D, and then I will compare the values, right? So if I want to calculate pressure at point A, I must have a pressure value at any point above A. So let me mark a point G which is on surface of water above A, and I can use the hydrostatic law between these 2 points, right, A and G. So using that between A and G, I know that pressure at lower point equals to pressure at higher point plus rho GH. So which one of these two is lower point? Pressure at point A. So PA equals to PG plus rho GH, rho of water, because in between G and A water is filled, and then G as it is, and then H1 is the distance between G and H. You put the values. PG is 0 Pascal gauge, rho W is 1000, that is water, G is 9.81 meter per second square, and H is 10 meters, because the distance between G and A is 10 meters. Now put the values and calculate. You will get 98100 Pascal gauge pressure at point A. So I will put the value. PA is 98100 Pascal. Now, let me talk about pressure at point B. If I want pressure at point B, I need to have a point just above B, which is, let's say, marked with a point H on surface of water. Again, pH is atmospheric and I can use the hydrostatic law between B and H. I will say that pressure at lower point equals to pressure at higher point plus rho GH. So, pressure at B equals to pressure at H plus rho W G, and again distance is H1. And if you put the values, pH is 0 Pascal, rho W is 1000, G is 9.81 and H is your 10 meters. You put these values in the equation, you will get pressure at point B is 98100 Pascal. Again, you will see the pressure at B is 98100 Pascal, pressure at A is also the same. So, now can I say that pressures are equal? Yes. So, the answer third, option third is the correct one. Keep this in mind. Okay. Now, let me ask you another question. What do you think? Because see, A and B, as per the previous understanding that they are located on a same horizontal plane, therefore pressure has to be same. Now, answer me this. What happens to pressure at point C and D? They are also located on a same horizontal plane. Do you think pressure at C will be greater than pressure at D? Or do you think pressure at C is less than pressure at D? Or do you think both of them have same pressure? Let us identify the answer. Again, here also we will calculate the pressures at both this point and then we will conclude. So, firstly I will calculate pressure at point C. So, for that I will project a point I on surface of water above C and also a point J on surface of water above D. Now, if I want to find the value of pressure at C, I can use hydrostatic law between I and C. Now, see what I will do. Now, look at this carefully. Yeah? I will say pressure at lower point equal to pressure at high point plus rho GH. Now, pressure at lower point is pressure at C, higher point is pressure at I. Now, question is rho G, H is what? H2 plus H3, H2 plus H3, right? Total height. Question is, what density will you use? Because in between I and C, you have mercury as well as water. So, which density will you use in this row? So, directly you cannot go for that. So, what you will do? You will break this into two halves. You will also mark a point E at the junction. Now, what you will do? Firstly, you will find pressure at point E using the hydrostatic law between I and E. And in this particular formula, you can use entirely rho of water. And then using pressure at point E, you can find pressure at point C by using hydrostatic law between E and C. And in that case, you will use density of mercury because mercury is filled between these 2 points. So, whenever you have this kind of confusion, what you do is you break this equation into two halves, you mark a point at the junction. So, now first let me calculate pressure at point E by using hydrostatic law between I and E. So, you can say that pressure at E equals pressure at I plus rho of water G and H2, rho of water G and H2. And use the values Pi is 0, rho of water is 1000, G is 9.81, H2 is 8 meters. You put the values, you will get pressure at E as 78480 Pascal gauge. Alright, you have put the values. Now, you will find the value of pressure at C using this particular value of pressure at E, and you will use hydrostatic law between E and C. So, how do you do that? Pressure at lower point, that is C, equals to pressure at higher point, that is E, plus rho of mercury G and H3. Put the values. Pressure at E is what? 78480. Rho M is 13,600. G is 9.81 and H3 is 3 meters. Put the values. See what you are getting. So, you will get 478728 Pascal as a pressure at point C. Keep this over here. Now, you find pressure at point D. So, for D, we know that you can use hydrostatic law between D and here there was a point J. So, for D and J, pressure at D equals to pressure at J plus rho W G and total H. H total is H2 plus H3 total. Right. So, Pj is 0, rho W is 1000, G is 9.81 and then H2 and H3 is 8 plus 3. You put the values, you will get 107910 Pascal gauge. Now, you compare the values PD and PC. Do you think they are same? No. Even though both of them lies on a same horizontal plane, but still the pressure are not same. Now, then what could be the common reason, common statement? Now, understand this thing. Common statement is, in a fluid at rest, the pressure at two different points lying on the same horizontal plane are same if the points can be connected by a continuous curve lying in the same constant density fluid. What does it mean? See, earlier statement said that points lying on a common horizontal plane, pressure will be same. But here the statement has been changed a bit. What they are saying? 2 points which lies on a common horizontal planes, pressure at both of them will be equal only if you can connect both this point by a continuous curve being in the same constant density fluid. That means you look at this. I talk about A and B. Can I connect point A and B with a continuous line being in the same constant density fluid? Yes, if you see all the points of this red color curve are in water. That means constant density fluid. If you can do that, then the 2 points which lies on the same horizontal plane will have same pressure, which we already found. Now, therefore, PA equals to PB and we calculated this. Now, do you think the same can happen for C and D? Do you think you can connect pressure, do you connect point C and D with a constant line being in the same constant density fluid? You cannot do that at all. Why? Because when you connect this with a curve, you will see half of the curve lies in mercury and a part of it lies in water. So therefore, if you cannot connect 2 points lie on the same common horizontal plane by a continuous line being in the same fluid, then you can say that the pressure at C and D will not be equal, and therefore you found pressure at C is different and D is different. Clear? Now what can you say about pressure at E and F? Use that law. Think about it. Firstly, do they lie on the same common line, horizontal line? Yes, they lie on the same common horizontal line. Now, can you connect E and F with a continuous curve which is totally in the one fluid? Let me check. Yes, you can definitely. You see all the points of blue color is in the same fluid called water, and therefore pressure will be equal at P and F. Clear? So I hope you understood this concept of pressure variation in a static fluid. Thank you so much. For more such conceptual videos, log in to our website www.clariconcepts.com. Thank you. We'll see you in the next class.